learn about transactions in SQL Server. So let's get started. So who am I? This is the must-have page. My name is Jimmy Ewald. I'm a data engineer. I was a DBA before I was a data engineer. I've basically been doing this stuff since I got out here. I'm from California originally, California boy, but I think I got more Okie in me than California, to be honest. I kind of like it out here. So that's been about 4.5 years, and I've enjoyed the heck out of it so far, doing anything data related. So I started off working with SQL Server, Microsoft SQL Server specifically at first, but I've also now gotten a chance to work with Hive, Athena, Snowflake, Postgres, and Exasol, and maybe a few more that I can't think of right now. So that's been a fun experience for me so far, but I definitely, SQL Server, I have a little bit more knowledge than the rest of them. I work for Interworks right now. We're a consulting company, and if your company needs any help with any of that stuff, you can reach out to me with your BI or any IT needs, and then other boring things, because nobody cares about this slide. So let's move on to what is a transaction. Does anybody, can anybody tell me what a transaction in SQL Server is? Are y'all just shy? Is everyone shy? John's not shy. John's like, hell no, I ain't shy. All right, well, that's good, because that's what we're talking about. We're just going to, I put up here standard read commit, because there's a few different things you can get into with dirty reads and things like that, but we're not going to talk about those. So if you're wondering, we're just going to talk about standard read commit tonight. The Microsoft definition is a transaction is a single unit of work. Basically, what that means is if you do anything to your database, you change the data at all, that's a transaction, okay? So that would be an insert is a transaction, an update, deletes, and changing the metadata. So changing from int to big int, things like that, that's a transaction, okay? Nobody could give a definition for transaction, but does anyone know what auto commit is? And if you just write a normal, like insert into, is that, and then you just hit run, insert into some values or select star from, is that an auto commit transaction? Who thinks, everyone's being a little tired, so raise your hand if you think a normal SQL statement like that is auto commit. We got one hand, two hands. You're going to have to raise your hand either way, by the way. So, and who thinks they are not auto commit? All right, most of the people raise their hands. That's pretty good, all right. It's cold out there. We should get our blood moving, get some exercise. Raise those hands. So normal SQL statements are auto commit. That means that whenever you run the statement, it commits it automatically at the end of the statement running. So the way you can avoid doing that, I'm pretty sure there might be a setting, actually. Bill, do you know if there's a setting that you can set it to where it won't auto-commit? I would imagine it might be, but I've never seen it turned on if it is. Yeah. Okay, so you don't think there's a way of turning off the auto-commit? Yeah. I'm not sure. Yeah, like I said, it might be in there, but I've never seen it. I don't remember it specifically. So one way you can avoid doing that is a begin transaction statement before you run your code. So if you start with begin transaction, that means that until you actually run the code commit transaction, your code will not commit. Okay? Question? Yes?
Extra piece of info. Set implicit underscore transactions on goes into implicit
Okay, there is a setting. Not Chuck John coming in with the, he's Googling in real time, fact checking me. Boy, that doesn't make me feel nervous at all.
No pressure.
Yeah. See how well I Googled before making this. So that's good. That's interesting. So what was it? Set implicit transaction
Set implicit underscore transactions
on.
implicit mode or off, which is the default from SQL Server.
Implicit or not.
Yep.
Interesting. I would guess that probably would not be a good idea to set everything to implicit, because then everybody would, yeah, something to think about, I guess. So let's move on to how data is stored. So there's 3 different file types for a database. Those 3 are MDFs, which is the primary data file. NDFs, which you do not need to have. You do not need to have an NDF, but you can have one or multiple NDFs if you want to. Those are secondary files for the data. So that's where the data actually lives, right, is on your primary or secondary files. So wherever you put those, that is where your database is, okay? And then lastly, we have the LDF, which is the log file. This is mostly what we're going to be talking about tonight. The log file is where transactions are stored. So transactions was what we talked about on the previous slide, where they have, where you have updates, inserts, deletes, and metadata changes. Those are all written to the log file. Or typically it's the LDF is the file extension. You can name it whatever you want, but question?
Something that I run across is those are recommended file names. They can be used other things.
Yep. Yeah, you can change them. They don't have to be LDFs. Yeah. It's a little, you can be a little confusing. In fact, backups and things like that too, you can name whatever you want. Yeah. It can get really confusing if somebody wants to mess with you. You're like, what is this? This is not normal. So again, not recommended. It probably should be forbidden knowledge. Just forget I said anything. It has to be named LDF. Or it'll break. .LDF, yeah, exactly, right. So yeah, just for those who couldn't hear, Julie was just saying also that LDF, yeah, you don't need to name it a .LDF. You could name it .whatever, MDF, and get them backwards, and then it would still be your log file. It would just be .whatever you wanted to, and you can. It's just name it a .LDF to make things simple. Okay, so moving on, we're gonna talk about how these things work together soon, but we're just gonna cover the basics right now. So let's talk about database recovery models. There are 3 different database recovery models. The first one is simple. Does anyone know what the other 2 are? Julie knows, maybe? Full and bulk log. Look at that, even in order, full and then bulk log. That's impressive right there. That's why she gets paid the big bucks. Okay, so first, we're going to just cover what all these mean. So whenever you have a database in SQL Server, again, and if I'm really, I'm trying to explain this for those who don't know anything about how databases are or anything like that. So if you already know and you're like, yeah, this is all whatever, then sorry, hopefully you still can get something out of this talk, but this is really trying to keep it beginner as I can. So let's talk about the full recovery model. In full, this is talking about the transaction, the LDF, the log data file. All transactions are recorded and saved in the LDF. So if you make a change, if you update a record, that update is recorded in the log file, okay? And that means that if you inserted 1 billion rows all at once, that would all be written to the log file, and it would stay in the log file. So if you put a billion rows in, and then you put another billion rows in, you put another billion rows in, every billion, it's keeping all that billion and the previous billion. Okay? It'll just keep those in the log file. There's a few things that we can do to get it where it won't, where it'll truncate the log file, where you can rewrite old data in the log file. But unless you do those things, it will keep those transactions in the log file forever. Okay? So this is why if you're doing development or something like that, it's important that you watch out, because if you have your recovery model as full and you're doing a bunch of changes and you're adding all this data and you're manipulating all these things, and it'll just, your log file just keep getting bigger and bigger and bigger because it will just hold on to that data forever. Now, how can we truncate the log file? Well, for full, you have to have three things. Okay? One, the transaction or transactions that are currently in process have to complete. Okay? So you can't be halfway through a transaction and then it fill up the log file, let's say, and then it go, okay, well, we're going to truncate the log file and then we're going to keep filling it up. Like, nope, the log file has to keep expanding until, if it can, it's got to keep expanding until your transaction is done. That's the first thing. And then when the transaction is completed, we can go to number 2. The data has to be backed up. And does anyone know what kind of backup we need to do in order to truncate the log file? We'll talk about it in a second because I have a backup. Julie, you have all the answers. Hold on. We're going to move on to backups in a minute. But something to think about. So you have to back up the data, and then if the data is being replicated, it also must be replicated. Like, the data actually has to move. It's a terrible sentence. I actually meant to reword that, but oh well. So if the data is being replicated, it has to be replicated. It just means, so if your data is being replicated, you have server A and server B, and the data is got to be matched across both of those servers. Okay, that's what replication is. It's got to be on one set of hard drives and another set of hard drives. Okay. So if you are doing that, you're replicating, then the data has to have made it to the other server or the other hard drive, right? Before you can truncate the log file. So let's say you inserted 1,000 records and they went into server A. All those changes have to have made it all the way to server B, where the data is being replicated, so that both of those databases are the same before you're allowed to truncate the log file. Okay? So it'll just hold on to that log file. So if you have broken replication in your let's say that you have a transactional system. Okay, so that means that you're having a bunch of data that's constantly flowing into your database. Okay? So it's just constantly flowing in, constantly flowing in. It's really important that you get your transaction log file, your log file truncated, because if you don't, you have a constant stream of changes coming in, a bunch of transactions, and if you don't do anything about that, it's just going to keep getting bigger and bigger and bigger and bigger and bigger, right? So what can happen is let's say that you are backing up the data and all those transactions just keep coming in, but your replication breaks. So it says, I know I have a point B where I need to take all this data over to. Well, it can't just get rid of that data without sending it over to the other one, because it's got a job. It's supposed to replicate that data. It's holding on to those changes until the other side knows what to do. So if you have a network problem or something and your data doesn't make it over, that primary database is just, that log file is just going to keep growing and growing and growing until you replicate the data over. Okay? Does that make sense? Does anybody have any questions about any of that? Okay. So we're just going to move on to simple then. Simple is another is our next recovery model. So, are all transactions written to the log file? So in simple, still most of your transactions are going to have to be written to the log file. This is something that when people think about the log file, they think, well, I have simple recovery model, and so that means that my transactions aren't actually written to the log file. That's not true. Now, it might not record everything in as much detail as full, and I don't know the specifics on that, but I know that there's some small differences there. Also, by the way, this thing's real finicky, so make sure you let me know if these go off, because I'm like touching this thing, and if I shake it, it's gonna be real ugly, and then you guys won't be able to see. So anyway, most of the transactions are still written to the log file. So what might happen is if you have an incorrect assumption as to what simple recovery model does, is you'll think, oh, I'm going to make a big change. Like, let's say that you're going to rebuild an index, right? You're going to rebuild one of your tables. So that can take up a lot of space. It takes up, because you're reorganizing everything. You're taking your entire table and you're going to put it in, basically you're going to take it and reorganize the whole thing. You're going to have to store this over here, and then you're going to put it all back in. So that can blow out your log file pretty easily. If you have an incorrect assumption as to what simple does, you could think, well, I just need a real small log file because this database isn't simple. No. It still has to be written to the log file. You still write to the log file. The difference between simple and full is that you don't have to back up your log file in order to truncate the log file, if that makes sense. So if I inserted 1 billion records into a table at the same time, one transaction, it would all be inserted, and it would have to use that much space in the log file, okay? Now, after that transaction is done, you don't have to back anything up. In your next transaction, we'll go start overwriting. It'll truncate whatever's in there, whatever's in your log file, and it'll start overwriting it, okay? So that means that your log file won't continuously blow up like in our previous example, right? It'll just, if you had a real big transaction, it still has to accommodate that, but it won't continue to expand, if that makes sense. I might not have done a very good job explaining that, but yeah, it's real important for, like, if you're going to do, like I said before, development and things like that, to keep in mind whether or not you want to use simple or full recovery models, okay? Yeah, and that's all you have to do to have that log file truncated. Another thing is you can't replicate the data, because like I said before, whenever you replicate things, you have changes on A, those changes need to make it over, they need to follow over to point B. Now, if you have a database that is constantly overwriting transactions, that's just not, you won't be able to replicate it all, because if it doesn't make it to the other side, and it just gets truncated on side A, then side B won't know what the changes are. They already got overwritten, if that makes sense. Bulk log is our last one. We won't spend too much time talking about it. Bulk log is basically full, but if you're going to make a giant insert, a bulk insert, you're going to insert a bunch of records at the same time, you're going to be, it'll take up less space in your log file. So it's still going to take up space in your log file, but it's going to take up less space. And it's for the specific instances when you're doing a bulk insert. Now, I didn't double check this, but I think there's a chance that you can use replication with bulk log, but I've never seen it, but I think you might be able to. I'm not real positive about that. Like, so if you were replicating your data and you switch to bulk log because you have this huge insert you have to do, then that might be a possibility, but I'm not positive. So similar to full, it's the same thing with bulk log. The transaction has to complete, that doesn't change, and then the database has to be backed up. And again, if you can replicate, then you also have to replicate the data as well. Moving on to backing up databases, there is 3 different backups. I'm just going to show them all. You have your full backup and differential, a lot of times referred to as diff, and your transaction log, T-log, your log backup. So let's just cover real quick what the 3 backups do. Your full backup is a snapshot of the database in this instance, the entire database, okay? So if you take a full backup right now at 6:39, that will be the database as it is at 6:39 when the backup was taken in its entirety. It matters sort of when you're restoring things, okay? We'll cover that in a second, but that's what full is. It's the whole database. Differential backup is the changes in the database from the last full. So I'll say that again. Differential is, it records the changes in the database from the last full. So if you have a 2 terabyte database and you take that backup, that's going to be 2 terabytes worth of data, okay? Because that's the size of the database, and you're taking the entire database and you're backing it up. We're not going to talk about like compression and other things, but let's just say 2 terabytes, 2 terabytes. Now, differential, now let's say that it's been a whole 24 hours, it's been a full day, and there's been very minimal changes. There's been a handful of changes. Let's say that there's been 10 megs of changes. Well, then your differential is going to be really small, around 10 megs, because it's only recording what's changed since the last full backup, okay? Now, transaction logs, this is our last one. These are also known as incrementals. So these are changes from the last incremental, the last transaction log backup, okay? So your transaction log is going to hold on to all the transactions, right? Does that make sense? So whenever you have a transaction, whenever you're restoring transactions, then you have to restore every single transaction log in succession from the last full or from the last differential, okay? This might start getting a little bit confusing, but it's not too bad if hopefully I can explain it where it sounds easily enough. That was terrible English. So once again, if you have, well, you know what? We have a slide coming up that hopefully illustrates it pretty easily. But let's move on to restoring databases just real quick, because like I said, the backups really matter whenever we're talking about restoring. That's what matters. Actually, let's go back to this real quick. We talked a little bit earlier about if you have full or bulk log, your transaction log will only be truncated after you back it up and the transaction's finished, and if your database has been replicated, if it is being replicated. You could have just a standalone server where it won't be replicated, and then you don't have to worry about that. So Julie thinks she knows. I want to know if anybody else thinks they know which one of these backups will allow your transaction log, not you either, Bill, cheater. Which one of these backups do you need to take for your transaction log to be truncated? Does anybody have any guesses? John guesses full. Anyone else? You also think full? You have a guess? Okay, everybody's thinking full. It's actually transaction log, which I think Julie knew. Your transaction log backup. So it's sort of interesting. You have to take T-log backups if you want to truncate your trend. It's actually something that I had to think about earlier. It's been a while since I've been doing a lot of backing up and things like that. In my new job, I don't have to back anything up anymore. It's just not what I do. I was like, oh yeah, the full doesn't work, because I was like, how does this work again? But it's the transaction logs are what need to be backed up in order for you to truncate that log file. So that's something really important to know, because if you're only taking fulls, then you could have a problem.
So a full isn't truly a full then?
It is a full, but it won't allow you to truncate your log file.
So does a full
It contains everything, but
does the full back up the transaction log, or does it just back up the NDF?
it's just what the database is. So those primary and secondary.
Primary and secondary.
Right.
Okay, then I get it.
Yeah. So that's the difference, is that all the changes aren't recorded whenever you have the full. Because that's what the transaction log file is, right? It's just a recording of all the changes. That's what it is. So that's another problem, though, is that because even today, I was thinking to myself, oh, but if you just take fulls, that should be fine. No, it's not fine. Your log file, you might continue to blow out, and you'll be wondering why. It's because you're not taking your log backups. It doesn't seem like something that you need to do, or something that you'd think that because full is all-encompassing, that would be part of it. But actually, you need to take those log backups. Interesting stuff. So if you're ever thinking, like, why is this log file blowing out? Like, make sure you double check those things. So I have a crazy insert that's going right now that's just been, or am I rebuilding things? Am I rebuilding all the tables or something like that? If you rebuild all the tables at once, that's going to be, because like I said before, if you rebuild your tables, that's taking your entire table, and you're basically putting all that data into the transaction log, because you're rewriting everything to put everything, you're defragging whenever you rebuild. So if you do that to all the tables in your database at the same time, you can really blow out that log file. And if you don't take those transaction log backups, then that's where you can start seeing those issues. So let's talk about restoring a little bit. So using log backups, which are those incrementals that we keep talking about, what's really nice is, because log files record all the transactions, when we restore a database, we can restore to a specific transaction or a specific second in time. You can go back I want it to be 12:01 a.m. 12, let's say, midnight and 1 second. Then you can do that using transaction log backups. Or, like I said, you can go down to a specific transaction. Oops, this is the button that was pressed that messed things up. So I'm going to compare databases. I'm going to restore side by side and look, and I'm going to go back to what the data looked like before this transaction was run. You can do that. You use the transaction log backups. Now, like I said before, logs are incremental and can be stored from the latest full or differential. Okay? So let's just look at a visualization, what that looks like, okay? So as you can see here, at 2 p.m., there was a full backup taken. Let's say that's the first full, and then 15 minutes later, we took a log backup. Then 15 minutes after that, we took a log backup and a differential, okay? So at 2:30, that differential is all the changes that have happened since 2 o'clock. That's what the differential is showing. So if you did a bunch of things in between now and then, but the data is mostly the same, like let's say that you inserted 1 billion records and then you deleted those 1 billion records, then that differential would be about the same size. It would be basically nothing, right? Because the data is the exact same. Now, you moved a lot of data. The transaction log would be very big because you inserted and then deleted 1 billion records, right? Your log backup would be huge, but your differential would be small. Because, like I said, the differential is the difference, the changes in the between the now and whenever the differential was taken in the last full. Okay. So then at 2:45 we have another log backup taken. Then at 3 we have a full, and then 3:15 we have another log. Okay. So let's say that we need to restore to 2:44 p.m., okay? We want to see the database as it were at 2:44 p.m., okay? There's a few different ways we could do that, but there's one way that's the most efficient way. John thinks he knows. What would we need to restore in order?
I would restore the differential backup from 2:30 and then as much of the 2:45 log backup to get the changes up to 2:44 p.m.
That's a good guess. So John says he thinks it's the differential backup plus the log backup from 2:45 up until 2:44. That sound about right?
Yes.
Okay. Does anybody know what John missed? Julie knows. Bill knows. Anyone else? We're missing one other backup. That's a good guess, John, though. There's one backup that's being missed.
Do I have to start with the full before I can do the diff?
You have to start with the full. So remember, your differential is only your changes from your last full, right? So you could have a 2 terabyte backup in that full, and then that could be a 1 meg differential. So if you tried to restore 1 meg differential and then the log, which is just the changes, you're going to be missing a lot of data. It just wouldn't work, but just conceptually, you know. But that's that was pretty good. The same thing with, now another way we could do it, which is less efficient. Well, John's really excited about that one. John knows the less efficient way. Okay, what do you think, John?
I know the less efficient way. I go the 2 p.m.
2 p.m. full.
The 2:15 log.
2:15.
Log, and as much of the 2:55
Yep.
log in it.
Right, you can just skip the differential. Yeah, you can just do all the full from 2 o'clock and then all the logs, right? Now here's another thing that you could do. Let's say that you needed to restore at 3:15, right? You could restore your full backup from 2 p.m. and all your logs until 3:15, but that wouldn't be very efficient, would it? Because you have a full at 3 o'clock. So you could just take that full at 3 o'clock and then restore to 3:15, and then that would be the most efficient way. Oh, we have questions all over the place. Let's go over here first.
Let's say you wanted to restore, like you were saying, sometimes we just put out at 3 o'clock. Could you use the 3 and then walk it back?
That's a good question. So the question is let's say that you wanted to go sometime in between 2:45 and 3. As you'll notice, there's no log file at 3 o'clock, just a full, right? So it actually would probably be better if we did put a log backup at that time too, because to answer your question, you can't go to a specific point in time before 3 o'clock because the transactions aren't recorded in the full backup. So in order to go, what would we need to restore to go to well, that's actually really interesting. What?
I just wanted to point out that we have a Twitch user, Skull Crusher here.
Skull Crusher.
Skull Crusher's still alive. He's getting all of these right in chat.
Oh, he's getting all of them. Is that all you wanted to say?
Yeah.
Okay, Skull Crusher and Chaz getting them all right. Nice job. He must be a regular that just couldn't make it, or she. It could be either one. So what you'd need to use to answer your question is the log backup, though. So the 3:15 log backup would have your... now, I believe you would probably need to use the 2 p.m. full backup at that point. So because it's before the last full, right, you would still need to get the data from before the 3 o'clock, because in our scenario, it's 2:55 or whatever. That's before the 3 o'clock full. So even though, as we can see here, the log file encompasses the time between 2:45 and 3:15, we have to use the full from before 3 o'clock because we're going before 3, right? So in that case, at 2:45 or whatever, or 2:55, let's say, we'd have to use the 2 o'clock full. We'd use the 2:30 differential, the 2:45 log, then the 3:15 log. Then we could choose, when we got all those tacked on, we could go back to 2:55. So it would make more sense to do a log file at 3 o'clock as well. There's no reason to not have one. I mean, it just, I don't know why I didn't put one in there. We're just for the sake of an example. But it's a good question. That is a really good question. But yeah, we'd want to use the full, the differential, and then you'd have to use 2 logs, and then you could go to 2:55. So we had Julie, I think, had a question.
You could not restore the full and unlock the full because the full.
No. Right, you couldn't restore 2 fulls. It's just 1. Correct. Sorry if I misspoke that. Yeah, you can only restore 1 full at a time. Now, the differential, so like I said, for the logs, they all stack, right? So let's just imagine that at 3:30 there was another differential, right? Or let's say that even at, let's say this, at 2:45 there was another differential, right? And let's say we wanted to restore to 2:45. Can everybody imagine we want to restore to 2:45? And we have 2 differentials now. We have a differential at 2:30, and we have a differential at 2:45. So would we need to restore the full and then both differentials, or the full and just the 2:45 differential? Who thinks both differentials? Who thinks, we got 2, who thinks just the 1 differential? Just go with whatever Julie thinks. Julie's right, you just need the 1 differential. Remember, the differential is just looking at changes from the last full.
If you were to put differentials inside that recovery, it would exclude one of them automatically. So it's not something you really have to pay attention to. If you're unsure what you have or what you want,
How do you know that?
it will automatically exclude recovery.
But that's if you're using the Julie, if you're scripting it out and passing it.
That's absolutely true.
Wait, so Bill's claim is you can include both differentials and it'll still work. How does he know that? I don't know. He must have done it before. Okay, so actually that means that everybody who voted was right because they both work. You're just wasting time. I mean, like it's a little bit more work to do both differentials, but apparently you can do it. But everybody's right. Okay, let's just talk a tiny little bit about replication because it does have to do with transactions. So we're going to talk about, that's replication meaning mirroring, log shipping. In 2012, they came out with this thing called availability groups. That's just replication, but to be replicating in 2012 onwards, you put your database to be part of an availability group. And then that availability group is defined as being over whatever servers you got going. So like we already talked about this a little bit, so this won't take very long, but transactions are written to both sides. Just to talk real quickly about synchronous and asynchronous replication. So synchronous replication is where you complete a transaction on side A. So side A is your primary server, okay? You write your transaction to that server. Then before the transaction is committed, the transaction must make its way all the way to the other server and actually complete that all the way over there before it'll commit on both sides, okay? So if you try to make complete a transaction in a synchronous availability group or mirror, then you have a break, right? So the replication is broken. The data is not it can't communicate to the other server. Then the transaction will not complete because it's saying, hey, I need to complete on both sides, but I need the 2 thumbs up. I'm giving a thumbs up. I'm waiting for a thumbs up from server B, my partner server, and I'm not getting it. I can't hear anything, so we're not going to complete the transaction. Okay? So that's synchronous replication. If my understanding is correct. I sound really sure about that, don't I? So then asynchronous is different. So let's say that you have 2 servers that are way, way far apart. So you have a lot of latency. You have a lot of time to hear from the other server. So one problem would be is if you had synchronous replication across a really long distance and you had to wait all the time, you could have your server waiting a lot for the other server, right? So asynchronous just says, we finished on this side, we're giving the thumbs up and we're moving on. That transaction is completed, okay? It's going to go to the other side, and now what can happen is if stuff breaks or you need to fail over and the transaction didn't make it to the other side, you can have problems there. So you'd rather go synchronous, but sometimes you just can't. Okay? So that's the difference there. Difference between the two? That is it. So let's move on to just a few last things, tips and tricks. Okay? This is something we talked a little bit about earlier with transactions. Here's an example SQL statement about transactions. So if you start with begin transaction, you can name your transaction. I actually recommend that because then you know which transaction you're talking about. I'm going to name this transaction Bill. No, transaction, and then you can insert all your data. So in this particular example, we're inserting data from to table A from table B. Right? And we're just going to go from every day before today. That's what this says. Where calendar date is less than get date, where the date is less than today. Now, as you can see here, I have commit transaction as an option that's commented out, as well as rollback transaction, which is also commented out. Okay? So I can run this script. It'll begin a transaction, it'll insert the data into the table, but it will not commit that transaction until I tell it commit. So the data, the actual data won't be changed until I tell it commit. So that's good if you're doing things on production, right, and you're making data changes, because if you mess something up and you press F5 and you run that data, then you go, oops, I didn't mean to do that. You mess something up big time. Don't worry, it's wrapped in a transaction. You can roll it back. Now the problem, can anybody think of a problem with doing this way? Julie has all the answers.
If you leave the transaction open, neither committed nor rolled back, then it blocks stuff. It causes all kinds of issues.
That is exactly right. So what Julie said was, if you do not commit your transaction and you do not roll back your transaction, guess what? You can't do anything on that table. It's locked until you commit those or roll them back. Bye, Addison Group.
Thank you. I'll see you guys on the table.
Awesome, thank you. So that is a problem, especially if if you have a transactional table that you're working with. You're always inserting records. And you block that, then you can really cause issues. So really important to know where you're doing this and be careful about it. What do you have to say about it, Bill?
So what happens if you use something that, like a truncate, or a drop table set transaction?
You can roll it back. So what he said was, what happens if you truncate a data set in a transaction? I think so. Can you not? So am I lying? Is that what you're saying? Just tell me. They're not logged. Really? Might be something to look into, I guess. Well, yeah, but it also deletes row by agonizing row. deletes do. So if you delete everything, it's going to go row by row and log every single row that is deleted, where truncate gets the whole thing. So maybe, yeah, maybe you couldn't rapid truncate. I wouldn't try on production data. I'll just say that, all right? You don't have my endorsement there. I'm surprised that John hasn't Googled it yet.
I just did.
What does Google's tell us?
Well, some people say that you can roll back a
Truncate?
if you use transactions in your code.
Okay, so some people agree with me,
Yes.
and others do not. Are you checking too?
Oh, yeah. So you get the answer from both sides. You get the drop and you get the answer that you can't.
That's it. Time to practice and prod. Let's go.
This is where everyone needs to go ahead and take this as homework.
Okay, so Bill asking the scary questions. If you begin transaction and say truncate table, it may or may not come back when you hit rollback. We don't know. Seems like the internet is fairly split on this one from what I'm hearing. So anyway, just be careful. Be very careful. This is like we're trying to be as careful as possible. That's why we're beginning transactions. But also, if you're blocking other things, that's a problem too. So, just keep those things in mind. Another tip and or trick, we want to separate our MDFs, NDFs, and LDFs. I have lots of questions here. So just a recap on these, what are the differences? MDF is your primary data file. NDF is your secondary or data file or files. And your LDF is your log file. So you have to have an MDF, you have to have an LDF, although you don't have to name them .ldf. But you have to have a log file and you have to have a primary data file. And you can have several secondaries if you want, or just one. So those are the differences there. Just a recap. Here's a quick side question. Which one of these files, or all of them, which one should we put on the C drive? We have an answer over here from John. None of them. That is correct. So you typically, he's right. That's where your OS is going to be. So what the implication there is, and I try to talk about this a lot whenever when I'm speaking, is if you have data problems and your database blows up or your log file or any of these things and your drive fills up and it's your C drive where your OS is, if it fills up, everything shuts off. Your whole server will go down, whatever you have running on C, because it ran out of room and it panics and it starts screaming and things catch on fire, and maybe not that, but it could happen. So the answer to that, it was a trick question. None of them. And John was quick. He's been spending time with Julie, you can tell, because he got a right answer. So let's talk about what happens if the primary or secondary file. So, okay, here's a few things that can happen. So let's say that you put your primary data files on their own drive. Okay, and they fill up. Will your OS won't crash because it's on a different drive, right? So that's one of the good things about doing it that way. But what will happen if, let's say, you're trying to insert a record into a database and the drive fills up? Does anybody know what will happen if the drive is filled up and you try to insert a record? Julie? It does not. The question was, does it? Don't give me that look. I don't believe it does. Okay, I could be wrong. Here, I'm just going to throw this out there just real quick. I'm just telling you what I think will happen, but we got the fact tracker Bill back there. So he gave me a look whenever I said no. Julia asked, does it matter what the recovery model is, right? So if it's in full or simple or bulk logged. That should happen with simple. So you think it might be different on simple? Might be. Or you think or you're saying it will be? It's just a bunch of people that don't know what we're talking about giving presentations. So I think that, so like I said before, with this simple recovery model in comparison to full or bulk logged, the difference is that after the transaction is completed, then the log file can be truncated if you're in simple. It'll just be like, okay, done with that, you can get rid of it, it's garbage now. But if you're in the middle of a transaction, it still should be holding on to that. So what should happen is if you're in the middle of an insert, then it'll roll back that insert. I think that's what will happen, and it doesn't matter if you're full bulk logged or simple. But Bill is contesting that, and I will be honest, I've never tested this before, so I'm actually not positive. In either case, it should free up that a little bit of space, is what you're saying. After it fails, right. Well, so that's a good question. Well, so that we're talking right now about the primary or secondary files. Right. Correct. I don't know if it'll write. The question is let's say that the MDF is full and you try to write to the MDF, then will the changes still be written to the log file? Right. If the log file has room. Like let's say that we have a D drive for primaries. Thanks for coming. Nope, Twitch cannot hear a single thing that's going on. Yeah, I sort of got distracted and yeah, that's what I figured too. So the question was if the primary or secondary data file that you're trying to write to, if that is full and the drive is full, so it can't grow, right? So there's no room to insert anything or make changes like that, then will the log file still be written to? And the answer to that, we believe, is no, because whenever the way the transaction works is it writes to the log file and then it ends up, the changes, once those commit, those changes are made on the primary or secondary, wherever you're writing to. Okay, so use checksum while backing up your databases because that can put you in the clear for corruption because otherwise you might have bad backups, and then test them as well. Yeah, tested backup is the only good backup is a tested backup. Otherwise, you don't know. It's an unknown. Okay, so the same thing, when the log file fills up, it's really similar to, now, basically what happens with the log file is that whenever you run out of room in a log file, it's going to auto-grow. We're not going to talk about auto-growth tonight. I'll save that for a lightning talk, I think, because I could just talk about it for a long time. But basically, your log file is going to just grow automatically at a certain rate. And once you run out of room for your log file to grow, and you need it to grow, that's whenever you're officially out of space, if that makes sense. Bill has given me a cheeky grin.
So you're saying you're going to tell the auto because it can take over the rest of the presentation?
We'll save it for another one. Yeah, Bill's he's trying to, like I said, be cheeky back there. So what happens if the log file fills up? Basically, you won't be able to do anything because you need to write to your log file in order to have transactions complete. And if you can't have a transaction complete because you don't have any room, you'll have failures. And Bill just fell asleep. Okay, so this is going to be the last slide, and then you can go home. Unless you're watching from home, then you're already home, and then you can just stop listening to me. Thank you, everybody who joined, including Skull Crusher, whom we may or may not know. I don't know. Okay, so we do know that he is a regular Skull Crusher. Oh, they are. He or she. Oh, I see. They're a regular from Florida attendee. That's awesome. So we talked about this a little bit earlier, not really a whole lot to talk about, but just remember things like if you're in test or dev, if you use full and you don't back up, your log file can just blow away the heck out. And similarly it's true in production as well. Those transaction log backups are really important to make sure that your log file doesn't blow out like crazy. Another point?
I would say this is a very good tool to follow overall, but if you have data that you can quickly reload from the source, even if it's production, you may not be as overly concerned about full recovery for something that you know you quickly reload in the analytic layer.
You mean like even in production or something like that? Yeah, Bill's point is that if you have something you can quickly rebuild really easily, it might make sense to just, even in production, keep it in simple if you're not replicating, because if you need to rebuild it, you rebuild it, and then you don't have to worry about these things like the transaction log filling up. So I have some sources here. So if you want, I can make my slides available. Just ask me on Slack or Meetup. Did you just tell me no? Oh, I said just contact me on Meetup. Can we post it to Meetup? Maybe, I don't know. I've never posted. There might be a way to do that. Yeah, I could just do the links, that's true. But then that wouldn't be the slides. I was just thinking about making the slides available. I could do that. Bill suggested me putting this on Google Drive and then just supplying the link there. That would probably be pretty easy. But anyway, yeah, I hope that was not too all over the place and made some sense. Transactions are something that they're not super difficult, but if you don't know what you're dealing with, they can be a real pain in the neck. like I said, a big one that I know a lot of people don't do is they don't separate their log files from their primary data files and their secondary data files. And they don't separate those off of C sometimes, where their applications are installed in their OS, which is danger, danger. And it's really smart to separate those files out. And if you do things like rebuild, if you rebuild a bunch of tables all at the same time, you can blow those log files out. And that's why it's really important to know what you're doing and ways you can get around that. Yes, Bill.
We did have one more note from Skull Crusher.
Okay, Skull Crusher.
Out that you have unscheduled full backup, and you take full backup at any point in there, and you do not use with copy only, that it will become your new point of backup.
Yep, that's a really good point.
Make sure that that's maintained.
Yes, so,
If you're ever curious where that goes, you can see that as
sorry?
you came to the backup piece that's
Yes.
and
And find, yeah, and where it went, yeah, where, okay, so the point, thank you, Skull Crusher, crushing skulls and making cool, nice database comments, pointed out that if you take a full backup that's not scheduled, so before, let's just go back a little bit. Oh, wait, almost there. Okay. So if we took a full unscheduled backup at 2:17 p.m., what could happen is that this differential that gets taken at 2:30, that differential only works from the last full. Remember that, okay? So if you took an unscheduled backup at 2:17 and you tried to apply the 2:30 differential to the 2 o'clock full backup, you would get a failure. It wouldn't work because you took a full at 2:17. So there's another invisible one in there at 2:17 right now, a full. So that can cause problems because it's like, why can I not restore to 2:30 p.m.? I am using my full, I'm using my differential. I know I only have to use one differential. What is happening? Now what you can do is you can go to the backup media set and you can search by fulls, and you can see when the last full. Another thing you can do is if you're taking an unscheduled full backup, is you can do copy only. That was a point that was made by Skull Crusher. If you do copy only, then it won't affect things like differentials. It'll just like, okay, that's just your own to the side what ad hoc backup, if that makes sense. That's a good point for backups. I love talking about backups. But that's going to wrap everything up.